Now, in exercise 3.5, I'm going to do a similar sort of example, just that, suppose I have something like this, and maybe this, oops, I was brushing something off the screen. Maybe this goes out to 3. And, the question is, what's A up here if that goes out to 3 and we want this thing to be a CDF or a PDF. Let's see. I think, this is a PDF. Okay, so this is little f of x. So little f of x here. Well, so what I know is, in this case, I could write this as this is equal to, what's the slope here? It's a over 3, right? So a over 3x. So I know that this function is a over 3x, and so now I want the integral from 0 to 3 of my f of x dx, which happens to be the integral from 0 to 3 of a over 3x dx. That needs to be 1. Okay, so, because I need to get to a total area of 1 under there. And so I evaluate this integral. This is integral from 0 to 3 of a over 3x dx. Well, that's a over 6x squared from 0 to 3, which is 9a over 6. That's an a, that's a 9. And that needs to be equal to 1, and so a is equal to 6/9, or better, 2/3. Okay, so we have that our little f of x is equal to 2/3 x. And that is for 0 less than or equal to x less than or equal to 3. Or as they do it, I guess, maybe you'd say strictly less than 3. And, it says make the approximate graph of this thing. And, since I did it there, I can do better than an approximate graph. But this goes back to Calculus 1. And, if you look at this is the derivative. Draw the antiderivative from it. We will start at 0. So that part I know, because everything to the left we get 0. But then, this is, the slope is increasing. Okay, so again, this is the slope of the CDF, and so the slope starts at 0 but gets bigger and bigger and bigger. Oh yeah, it sounds like a quadratic kind of, right? And so I would get something that looks like this. There's 3, and then it would take off flat after that. So there's x, and there's y, and there's my CDF. Determine the probability that x is greater than 2. Okay, so the probability that x is greater than or equal to 2 is just the integral from 2 to, now you could put infinity here. I'm just going to put 3 because that's all that we use is to 3. But, up here, you're sort of going to infinity. But again, the PMF, PDF, the density function is going to be 0 once you get past 3. And, right, so once we get past 3, we have 0 for a value. So I'll just go from 2 to 3, and that is 2/3 x dx. And so that is, wait, did I get that? Yeah, 2/3 x, okay. So that is 2/6 x squared, evaluated from 2 to 3. Now, when I enter 3 in here, I better get 1. If not, we'll go back and figure out what I did wrong, I guess. So I get 2/6 of 3 squared. Okay, so something's wrong here. So we'll put 2/6, I think. Let's see, 9, yeah, because that's 1/3. I should have 1/9 there. And 2 squared. Okay, but look, I know that's wrong. Now, how do I know that's wrong? Well, because I get, 1/3 times 9, but that's equal to 3. Well, if this 2 had been a 0 or something, I'd have gotten a probability of 3. That's wrong. And so I did something wrong back here. Now, I could delete this video at this point, go back, figure out what I did wrong, and start it right from the get-go. But again, you all have had me. The idea is that we need to be we need to realize that we do things wrong. How do we catch them? Well, I caught it because I got this 3 here. I should have gotten 1 from using that upper bound here of 3. I should have gotten a 1 out of that, always. So in that situation, if I am up against the right-hand side of a continuous distribution, and I do this integral and so forth, and I'm putting in that right-hand side, I absolutely should get a 1, because see, right there, I'm saying I should get a 1. And so I am going to pause this for a second to look at it, and then try to tell you where I had my error. Or if I didn't have an error, well, I had to have an error somewhere, but where I had that error. So I'll pause. Okay, yeah, so hopefully you were yelling at me in the video when I did this. So here, I said A is 2/3. Absolutely A is 2/3. But I forgot here that I had A over 3. And so F is not 2/3 X. F is 2/9 X. Okay, so now I come down here and I make that change to 9ths because I already was dividing by 3. And so now this is 2/18. And well, as long as I'm erasing, that 2/18 becomes a 1/9. And there I get my 1. Yay, and I need to fix this one as well. Okay, so erase all that. And I do indeed get my 1 minus 4/9, which is 5/9. Okay, so I got that. And then, and this is the main reason I wanted to do this example, was part D. So I guess this was part C. Part D, conditional probability. So the probability that x is greater than or equal to 2, given, oops, messed up my parenthesis there. Given that x is greater than or equal to 1. Well, by definition, that is the probability that x is greater than or equal to 2 intersected with x greater than or equal to 1 divided by the probability that x is greater than or equal to 1. But notice this intersection, that's just x greater than or equal to 2. And so this becomes the probability that x is greater than or equal to 2 divided by the probability that x is greater than or equal to 1. And in terms of area, well, let's go ahead and calculate this. Now, I know from up here, I get 5/9 for this one. And that's divided by, oops, the integral from 1 to 3 of my 2/9, got it right this time I hope, x dx. And so that's 5/9 divided by my 1/9 x squared, evaluated from 1 to 3. And so that's 5/9 divided by, I'll get my 1 minus 1/9 times 1 squared. And so that's 8/9. So I'll get 5/9 divided by 8/9. And I'll get 5/8. Okay, now in terms of pictures, you see we had this thing. So here's 3, and we want to, here's 2, and here's 1. So we wanted the probability of being in here, given we know that we were in here. And in that particular picture, if this area is, say, area A, and the diagonal area is area B, then what I want is the ratio of B divided by A, and that's exactly what we did. We took the integral from 1 to 3, which would be this area A, and we divided that into the area from 2 to 3. Or B. So we took that area B, divided it by the area of A to get that ratio for the conditional probability. So there we go. So even with the mistake in there, we got through something similar to 3.5.